hola.
You don't even have to introduce, like you're talking to the camera. You're just like, we're gonna have Jose and Pedro do this, blah 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 blah.
When you're ready, I'm rolling.
Action. So we're here again in the lab doing a demonstration of one of the labs we do in our structural analysis.
Say action when you're ready.
Action. I'm Jennifer Butler, a faculty member at OSU IT for the Civil Engineering Technology program. Today we are here with Josh and Bob doing a demonstration of one of the labs that our structural analysis class sees. This is going to be a tension lab. So we're using this equipment. We have some clasp at the top and the bottom. We're going to put an aluminum sheet into it and we're going to pull it apart. So we will first need to get it set up, grip it in the bottom, and then we can lower this equipment so that it's connected to the top. Let me know how close.
Cool.
A little more. That's
These have some little teeth in there, so they grab on pretty well. So we can give this a try. What you're going to see is that we have the computer set on tension test. It's going to raise this top part up. It's going to put tension force into this strip. And you may see a little necking, which is when it narrows at the weakest section right before it breaks. Sometimes the material will pop too whenever it breaks. Be a little bit of noise. So we will see what we get. Okay, so we've got it turned on. The graph is going to show the load that it's applying. So it's up to already 25, 50 pounds. And the other axis shows how far it's stretching. And it looks like we already got a failure across the top. It took 494 pounds, though, to get that failure. You can open it up, and then we can raise it up.
And it makes sense that it failed at its narrowest area.
We get stress concentrations around fillets, and that's something that we've talked about in class. And you could also measure the cross-sectional area and the load that was put on it and get the stress that it took to make that fail. So it's just a way to get some hands-on relationships between what we do on paper in class and what it really means.
Good.
Ready?
Okay, I'm rolling.
Okay, so we started the testing. The last one that failed took almost 500 pounds. This is at 300, 400. Yep, about the same. This is 623.4. So this one's a little bit stronger.
I'm rolling. Now I'm rolling.
All right. Here we are in the lab today. Oh, sorry, I missed it. I didn't introduce you guys. I don't need to introduce my students.
You are.
Okay,
They are.
cool. Got it. So I'm Gayan Herat, the civil engineering faculty in OSU IT civil engineering program. So today we are here to do a special lab session called the liquid limits and plastic limits for our soil mechanics sessions. Well, first of all, we have to receive a soil sample, which is passing number 200 sieve. And we're going to grab at least 500 grams of soil. Then we're going to point to another dish like this. And then we're going to mix with a little bit of water. So our ultimate goal is we're going to add the moisture to the soil until we get some kind of a blow counts, which is called 25 blow counts. So first of all, so you guys can add the water and make a kind of a paste. The paste should be in a dry area than in a wet area. Okay, you're going to add some more. Some more. Okay. Okay. All right, so I think we need to go ahead and add more soil because we need some kind of a amount of a paste that will fill the half of the little ball over here. Okay, mix it well. No, that water.
More.
Yep. Mix it well. The paste should be very evenly distributed moisture throughout the paste. I'm going to add a little bit of soil. Okay. All right, good. Okay, so let me mix it a little bit well. Seems like I need a little bit of more soil, then I can have more paste over here. So I'm going to add a little bit of soil. The only thing you need to remember is once you started this session, then after on you can add the soils after the first session of this practical. Until that, you can add the dry soil on it and make a amount of the necessary amount of the paste that you need. I think this is good enough. Okay, so you're going to use, so this is called the Casagrande, the instrument. So this is what we're going to use. So we're going to fill the half of the way of the soil over here. Yes, half of the way. Fill more. I'm gonna fill in more. Okay, good. Then make it a flat surface. I need a smooth, flat surface. Okay. All right, so I'll do the fine tuning. Okay, so this is the flat surface that we're supposed to make. So then we have the little grooving tool. So you guys gonna go ahead and make a groove at the center of the paste. Yes. All right, sounds good. Okay, now you guys gonna use this rotating wheel and count the blows until you get at least half of the inch of the connection from the two sides.
Okay.
Yes.
see that?
We're gonna get paste, little bit of paste over here
Where
with some
off of this?
from here.
Okay.
So we're gonna dry the sample for 24 hours overnight. Then we're gonna get the dry weight tomorrow. Then we're gonna get the amount of moisture and amount of dry soil in this little can. That's the recordings we need to go for our recording sheets. All right. Now, next step, you guys gonna go ahead and clean this up very well. Then add some moisture, a little bit of moisture for the paste, and do the same procedure again.
All right. Do we just put it back in the same
Yes.
bowl that we had in?
First on the
Okay.
on the sample.
How small does it have to be? Size of a pencil? That
Yep.
size right there?
Yeah.
Okay.
Okay. So
All right. So I don't need
I'll
the
tell
whole
them.
amount.
Yes, but you need to keep it somewhere over here. You're always going to refer this. I'm going to let them know. All right. Okay, you did that. Cool. All right. So this is called the second session of the liquid limits, which is called the plastic limits. So this is the soil paste that we already prepared with the Casagrande method, and we're going to use the little bit of soil over here, and we're going to roll it up like this until you get this much of diameter. This tool is available in the Casagrande method, so you can refer always this tool, and you're going to make a same size of diameter. When you make it, you need to make sure the surface of the little roll supposed to have some cracks, like crumble cracks. You're going to roll the paste until you're going to get the cracks. Okay, you can use your hands. Get this one, Bob.
My hands are very long.
Okay, good. So we can stop this, and then we can show the crack one later on. So it will take some time because they have to do it until it get dry, like that.
Just get cracks in it already.
Well, it's because I've been folding it back over and over.
I'll do this somewhere over here.
But it is getting a lot better. It's kind of hard to keep it at that diameter.
Yours is gonna get there.
That's because I
It will take a long time, so you just can't stop it.
Okay.
Yep.
I'm stopping it right.
Okay. Okay, guys, we're ready. So, so here is the way that we need to end up with. We have some little bit of cracks, which is called the crumble surface. Then this is pretty much the plastic limit of the soil. So we're gonna get some of the samples out from this, and we're gonna keep it over there for overnight or 24 hours, oven dry. Then we're going to get the amount of moisture retaining on this soil. So that's going to be the plastic limit of the soil. So each and every steps that we're proceeding from here, basically there are 3 steps, which is more than 25 blow counts, around 25 blow counts, and less than 25 blow counts. Then each and every steps you're going to do the same procedure and do the plastic limits and get the average of the plastic limits at the end. So that is pretty much the liquid limit and the plastic limit of the soils.
Ready to set it in it. Okay.